All right, so what I wanted to do was give you a little bit of a preview of the lab that we're going to be doing next week. Um, and you're going to be learning a law known as Hooke's law. Some of you had this in your first physics class. You might have done it with me or Mr. Hermano or Dr. Philauer or wherever you did it. But we're going to be looking at this now using some of our knowledge of AP physics. And specifically what's going to happen is that you're going to see some of the formulas that we simply took for granted in regular physics, we're actually going to derive using some calculus in AP physics. So this is going to involve a little bit of antiderivatives, a little bit of work. What I want to do is kind of lay out some of the ideas that we're going to be using. So you're going to be doing a lab next week. Some of you might have done this lab before, some of you might have not. But it'll be kind of a good review for those of you that have, and you can kind of help those of us that haven't done it before. So basically the setup's going to look like this. You're going to have a spring with a little hook at the end. And this spring is going to have an unstretched distance that we'll call x naught. And what will actually happen is that we will go ahead and put a weight on the end of the spring. And this is not, I want to actually really kind of make this clear. We're going to put some weight at the end of the spring like this, or rather a mass. So we'll put a mass of mass m here. And what we'll notice is that some stretching occurs on the spring. So we stretch from some distance x naught to some final position x final. So this is a displacement. And of course, what we can actually say is that there is work being done. Now, since we're stretching this distance, stretching through this displacement. Now, if we draw a free body diagram for this system, what we're going to see is that we have a spring force, a force on the mass due to the spring that wants to pull it back, and we have the weight on the mass due to the earth. And of course, if we gently lower this and let it settle, what we have is that the force from the spring equals the weight of the object. So what we're actually going to do in our lab is we're going to actually plot various different spring forces versus the position. And we're going to obtain some kind of a plot. Okay, so what we're going to do in our lab is we're going to obtain two things. We want a relationship between the spring force and the position. And then, of course, using what we derived in class, if this is a force versus position diagram, then we know that the area under this curve means something very important based on our knowledge of antiderivatives. So that's going to be the basic idea of the lab next week. We're going to actually have a whole little scaffolded setup, but I wanted to give you a preview of what we're going to be doing so that you are ready to come to class and get started on the lab when we walk in. All right, so that's kind of it for the weekend. What I want you to do is finish your projectile motion problems. Finish as many of the work and energy problems as you can. I want learning packets 8 and 9 done. We definitely want them done by the end of next week because we're going to actually start learning packet 10 in a couple days. So have fun and good luck.